Hello everyone, and welcome to this example recording on the source-free RL circuits. So the question we're going to be attempting reads as follows. For the circuit below, determine V0 for t greater than 0. So we're looking for the voltage across the resistor. So this question is slightly different from the ones that you ordinarily would do, because ordinarily what you'd be looking at is for the response across the element that is going to be storing energy, right? But now they're asking for the voltage across the resistor. But immediately you should notice that the voltage across this resistor and the voltage across the inductor is the same, so that should be V0. That's the first thing. The second thing to note is that if you remember when we talk of the response of an inductor, we said this is a current response. So we know that when dealing with an inductor, we've got IT is equals to, if it's a source-free response, it would be I0 e to the negative t over tau. And that is the current. Is this a source-free response? Yes, it should be, because the switch is opened at time t is equals to 0. So effectively this whole part of the circuit falls away at time t is equals to 0, leaving the inductor and the resistor. Therefore, the response would be I0 e to the minus t over tau. But how are we going to find V0? Because we effectively are looking for V0, right? So what we could do is we could have two approaches. We know that the voltage across the inductor is the same as the voltage across the 5 ohm resistor. So the voltage across the inductor we know is given by L di dt. So we could then differentiate, or we should differentiate the expression that we have on top here and then multiply it by the inductance to get the voltage VL, which is the same as VO, which we're looking for. Okay, so first step, at time t is equal to 0 negative, we need to get I0. And how are we going to do this? The circuit is active, so we have circuit that looks as follows. The inductor becomes a short circuit and the resistor sits in that manner. That's 5 ohms, that's 2 ohms, that's 3 ohms, that's 20 volts. Now what will happen in this circuit? Definitely the current that's flowing will move in this direction. When it gets here, it's got the option of 5 ohms or a short circuit, so it will take the path of least resistance, effectively reducing that to 0 or bypassing that value. Therefore we can say, and we were specifically looking for that current there, I0, so that I0 must equal to the total voltage, which is 20 volts over 3 plus 2 ohms, so we don't include the 5 ohms. So that's going to be 20 over 5, which gives you 4 amps. That's our initial current. So at time t is greater than 0, we will then evaluate the response, and we know that if you look at the original circuit, only the inductor and the 5 ohm resistor remain. So you will have a circuit that looks as follows. That will be the 10 Henry inductor and the 5 ohm resistor. And from this we should be able to deduce that R equivalent, which is RTH, must give us 5 ohms, and L equivalent must give us 10 Henries. And from that we can then calculate tau, which is L over R, which is 10 over 5, gives you a value of 2 seconds. And finally we can get the current. I, as a function of time, is going to give us I0 e to the negative t over tau, which gives you 4 e to the negative t over 2, which is the same as 4e to the negative 0.5 t amps. And then the last part is to determine V0, which is the same as VL, which is L di dt, and that is going to give us, is going to be given by the inductance, which is 10 henries, multiplied by derivative with respect to time of 4e to the negative 0.5 t, and this is going to give us 10 times 4 is 40 times negative 0.5 e to the negative 0.5 t, which gives us a final value of minus 20 e to the negative 0.5 t, and that should be volts, and that will be the voltage V output. So we were able to determine the output voltage by looking at the voltage over the inductor and then stating that that should be the same as the voltage over the resistor. So important to note in this question, yes, the response that should be going that should be associated with the inductor must be a current response, as we keep on emphasizing. However, they can ask you for a voltage response, and then you should be able to link the voltage and the current using that equation. Thank you for watching this video and enjoy the course.